that thing do? How come it's not? Why is that bar floating? What did they do to this?
I'm not sure. You did something.
I guess it doesn't matter. Alright, back to function relations. Relation and functions. When we talk about functions, we're talking, here's the deal. In order for something to be a function, first of all, if you remember, we talked about this. You have input numbers and you have output numbers. And all the time, every time you do one of those, graphing linear equations, that's like a relation slash function thing, because, if you had y equals 3x plus 2, if you input a 0, out comes a 2. You put it in the little formula. If you put in 1, you get a 5. If you put in a 3, you get an 11 or whatever there. For something to be a function, which is a specific type of relation, okay, it has to be this. And I always got to look at this to make sure I get it right. Every input number has exactly one output number. Which means this: if you were making some sort of a table with these x and y values or whatever they were, you could not have a 1 and come up with a 3, and then put that 1 in again, and the next time come up with a 2. Okay? Every input number has only one output number. Now the thing that confuses people is you can have the same output number for different input numbers, but it can't work the other way around. In other words, I could say if this is 0 and this is 3, that is fine. Or I could have 5 and this is 3. That can happen there, but it can't be the other way around. A lot of times we drew circles that look like this. You remember this from last year probably. You've got your input and your output, and we call it, this is called a mapping, where you have like 1, 2, and 3, and then this arrow would go to a 6, this would go to a 7, and this would maybe go to an 8. That would be a function because every input number you get just one answer out of it. Okay, something that wouldn't be a function would look like this as a mapping. You might have 1 and 2, and then you have 3, 4, and 5. I don't know why I keep putting lines there. You might have 3, 4, and 5. And if 1 did this, okay, that is not a function. It's still a relation because it's a relation just means they have pairs. Okay, but you can't have the same input number going to 2 different output numbers. Okay, it can work the other way around. This can happen. You can have 1, 2, 3, and 3, and 4. You can have 1 go to 3, and 2 go to 3, and 3 go to 4. Okay, you can have that because there's only one answer for every one of these. It can be the same answer, but it can't. Now, with that being said, here is really what the whole lesson was about. To find out a test for a function, and let's go back to this x and y thing. Let's say y equals, what, 2x plus 2, and I was graphing it, and 0 equals 2, 2 equals 6, 4 equals 10. I'm just throwing numbers in for x there. 1 equals, what, 4? If you graph this, you get 0, 2, 0, 2, 2, 6, whatever that is, 4, 10, 1, 4, okay, you get this line here. To test for a function, they have what's called a vertical line test. Vertical line test. And this is a big one in the world of math, so get used to it. And what the vertical line test says is this. First of all, you have to know what vertical means. What does vertical mean? Not horizontal line test. It doesn't work for horizontal, it's vertical. If you sat here and drew a bazillion vertical lines going through your graph, if you drew as many vertical lines as you possibly could, the vertical line test says that the graph will only cross any vertical line. Did I spell vertical right? Is it C-A-L or C-L-E? C-A-L, isn't it? Vertical line once. I'd say. Is that I'd say? Uno times. What's I'd say? Which means this. If you look at any of these vertical lines I drew there, this line that I'm looking at only crosses each one time. It doesn't cross any of them twice. Looking at some of these things here, let me give you some for example here. If you had this, here's my coordinate system, and my graph looked like this. And you tried the vertical line test. Oh, forget I did this part right here. Is there any place where I could draw a vertical line where that graph crosses more than one time? No, this is a function. Something that would not be a function would look like this. Here's my graph. And if what I graphed looked like this, the letter S, if I draw a whole bunch of vertical lines, you can stop right there because this vertical line crossed not only in one, but it crossed in 3 different places. So this is not, I repeat, not a function. If you graph a circle, is a circle a function or not a function? No, the vertical line test says not a function. Now, why would that be? If we go back and look at the mapping of that, maybe you can make this connection. Most of you will look at this since they're blankly and say that makes no sense to me. If I were actually putting down some coordinates for the circle, let's see, the circle is 1, 2, 3, 4. Here where x is 4, what y value coincides with that 4 value? Well, you've got 1, 2, 3. You've got y being 3 there. What's the coordinates of this point right here? 4, negative 4, comma 3. Negative 4 would go to 3, but negative 4 would also go to right here. 1, 2, 3, maybe negative 4. So you'd have the same x value going to 2 different y values, and you can't have that with a function. You know, it'd be every place you'd have 2. Any place you draw a vertical line to there, you're going to get at least 2, and you can't have that with a function. The function can only go one time through every vertical line. Take a look at page, oh, you don't have this. Write down this table here. Sorry, don't take a look at this. This is right out of the book here. 3, 2, 1, 2, 3. 3, 2, 1, 2, 3. And 5, 6, 7, 8, 9. 5, 6, 7, 8, 9. Would this table represent a function or not? Would it represent a function or not? Well, one way to look at it is you could draw a mapping of it What are my x values? I have 1, 2, and 3, right? What do those get mapped to? Oh, 1 goes to 7. 2 goes to 6. 2 also goes to 8. 3 goes to 5. And 3 also goes to 9. Function or not, yes or no? Maggie? No, because you can't have the same x value going to 2 different y values. Not a function. This one here, one more table. 2, 3, 4, 5, 4, 5. If you have 2, 3, 4, 5, 4, 5. Here's my table. X and y. Function, yes or no? Again, if you can't see it, you can draw a mapping of it. 2, 3, 4, 5, 4. 2 goes to 5, 3 goes to 4, 4 goes to 5. Is that a function, yes or no? Caleb? It is. You can have the same x value going, 2 different x values going to the same y value, but it can't be the other way around. As long as you just have one arrow coming off of the x, you're going to be fine. Notice in the one just before this, I had 2 arrows coming off the x value. And that can't happen with the function. I love it. Anybody else like it? I love it. Oh, I don't know what we should do. Words more.